Assalamualaikum and hi everyone. My name is Nur Alia Natasha binti Ahmad Faizal and my metric number is 240184 and I'm from Group 3. Today I will be presenting about our hydraulic project titled Capacity of Open Drain and Swale. Our group was assigned to assess two drainage locations here on campus. The first is near DSI and the second is along the left perimeter of the UTHM swimming pool. Urban drainage systems are a crucial part of campus infrastructures. They manage stormwater runoff, prevent flooding, and protect our built environment. Here at UTHM Parit Raja, with our tropical climates and ongoing campus development, maintaining efficient drainage is essential to safeguard pedestrian pathways, road networks, and recreational facilities. Our project specifically focuses on evaluating two selected open drains, which is one is near DSI and one beside the swimming pool, to assess whether they can effectively convey stormwater under full flow conditions while maintaining a safe freeboard. So as our campus continues to grow, more surfaces are being paved, which leads to increased surface runoff. Drains located near high traffic area like DSI and other recreational zones are particularly prone to blockages, sedimentations, and inadequate flow conveyance. These can result in localized flooding, safety hazards for students and staff, and potential damage to campus infrastructures itself. The purpose of our study is to examine the current hydraulic performance of these two main drainage that we assigned to our group and identify any deficiencies and ensures they comply with operational and safety standards. Our study has four main objectives, which are first, we aim to determine the physical and hydraulic properties of both drains, including their precise locations, dimension, longitudinal slope, type of lining, and manning roughness coefficients. Second, we will calculate key flow parameters such as weather parameter, flow area, velocity, and drainage capacity using manning equations. And third, we will assess their existing freeboard and recommended a safe freeboard for not less than 50 mm. And the last one, we will document all field data and analysis in a structured technical report to provide actionable insights for drainage maintenance and potential upgrades. It is important to clarify the scope of our work. This study is limited to the hydraulic assessment of two specific open drains, the first near DSI and the second along the left side of the swimming pool. Both are at the stated coordinates. Our investigations include field measurement of drains, geometry, longitudinal slope, lining conditions, and freeboard. Hydraulic analysis is based on the assumption of steady, uniform flow under full capacity conditions. Note that this study does not extend to the catchment hydrology, rainfall intensity analysis, or even a structural assessment of drains materials.
This slide explains the methodology used for the field measurements. Field measurements were carried out at the drainage site to obtain real on-site data. Manual measurement methods were used to ensure accuracy and reliability of the measurement. All observation and measurement were recorded directly at the site to reduce error and support later analysis. The photos shown illustrate the drain condition and the measurement process during the site visit.
Okay, this project holds several important benefits. First, it provides practical, field-based data on the performance of drainage in key area of campus, which can inform future drainage planning and management. Second, it enhances our skills as engineering students in field data collections, hydraulic computation, and professional reporting. Third, it supports UTHM infrastructure management by identifying drains that may require maintenance or improvement. And finally, it serves as a useful reference for similar drainage capacity studies in academic or institutional settings. That concludes my presentation on the introductions. So the next presenter will take over and present Chapter 2, which covers the methodology. Thank you for your attention.
Assalamualaikum, my name is Farah Artisha binti Muhammad Kharanwa, DF240145. So this slide shows the result for location 1, which is near Dewan Sultan Ibrahim, DSI UTHM. The length study is 3 meters and the drain used stone pitch lining. This type of lining helps to reduce erosion and control water flow. The manning roughness coefficient is 0.033, which is suitable for stone pitch drain. The bottom slope of the drain is 0.0025, showing that the drain has a gentle slope. The drain has a bottom width of 1 meter and a top width of about 3.69 meters. The total depth is about 0.88 meter, including a freeboard of 0.2 meters. The freeboard provides extra space so that water does not overflow during heavy rain. Overall, the drain at location 1 is safe and suitable for managing surface runoff in this area. This slide shows the hydraulic calculation for location 1. First, we calculate the effective water depth. The total depth of the drain is 0.88 meters and the freeboard is 0.2 meters, so the flow depth y is 0.68 meters. Next, we calculate the weighted parameters using the bottom width of 1 meters and the side slope of 1 vertical to 1.5 horizontal. The weighted parameter is 3.45 meters. Then we calculate the area of flow. Using the trapezoidal channel formula, the flow area is 1.37 square meters. After that, we calculate the velocity of flow using Manning equation with a roundness coefficient of 0.023 and a slope of 0.0025. The velocity is about 0.82 meters per second. Finally, we calculate the capacity of the drain by multiplying the area and the velocity. The discharge is approximately 1.13 cubic meter per second. In conclusion, the drain at location 1 has sufficient capacity to carry surface runoff safely.
Assalamualaikum. My name is Putri Namada. So today we are analyze the hydraulic performance of the drainage sections identified as a perimeter left side of the swimming pool at Utesham. So as shown, the flow direction is clearly defined for the specific infrastructure. To evaluate its capacity, the physical structure is modeled with a regular top width of 0.6858 meters and a total depth of 1.57 meters. The base features a semicircular channel with a radius of 0.29 meters, flanked by flat sections of 0.1016 meters. Okay, then next, to determine the total area, first we need to analyze the circular bottom segment of the swimming pool perimeter drain. Okay, based on a radius of 0.26 meters and a lateral distance of 0.24 meters, we use a trigonometry to find a central angle theta, which is 55 and 85 degrees, or 0.9748 radians. For our final segment calculations, we use the full central angle to theta of 1.9495 radians, and then we using the geometric formula for a circular segment, we calculate the area of this lower portion to be 0.043 square meters. Okay, then next we calculate the area of the primary rectangular portions of the drain by taking the top width of 0.6858 meters and multiplying it by the height of 1.57 meters. We find that the area for these upper sections to be 1.0767 square meters. So this area represents the main volume of the channel when water level reach the upper rectangular walls. By combining the circular segment and rectangular areas, we get a total cross-sectional area of 1.1197 square meters, and the total weighted parameter for the swimming pool left side drain is calculated at 4.47 meters. These figures allow us to determine the hydraulic radius, which is 0.25 meters, and the hydraulic depth calculated at 1.63 meters. Okay, then finally we apply the Manning's equation to determine the flow performance based on an upstream height of 1.57 meters and a downstream height is 1.606 meters over a 3 meter length. Then we establish a long longitudinal slope azimuth of 0.012. Then the with a roughness coefficient n is 0.013. So then we calculate the flow of the velocity is 3.344 meters per second, and this will result in a total drain capacity Q is we get the 3.74 cubic meter per second for the swimming pool perimeter. Okay. So in summary, the hydraulic analysis for the perimeter left side of the swimming pool provide us with a necessary data to confirm its drainage efficiency. So we have confirmed a flow velocity of 3.344 meter per second and a maximum capacity of 3.744 cubic meter per second. So this concludes our assessments of the hydraulic properties for this section.
Alright, Assalamu alaikum everyone and good afternoon. My name is Shahjul Al-Prashad. So today here I will be doing the presentation part for the conclusion. So without wasting any more time, let's just go ahead and start. So in this project, we studied the hydraulic capacity of the open drains, which is basically located near the Dewan Sultan Ibrahim and the UTHM swimming pool. And we also carried out field measurements to collect the important information such as the drain dimension, slope, lining type, and also the freeboard. And after that, we used the equation, which is also called Manning's equation, to basically calculate the flow velocity and also to discharge the capacity of the drains. And based on our results, the drains are basically able to carry a surface runoff effectively and also have enough freeboard to prevent overflow under normal conditions. And during our site observation, we also found that the drains are generally in good condition. However, there are like small amount of sediment and vegetation, which basically shows the regular maintenance is still important. And overall, if I say, the drain systems are functioning very well and also play a very important role in controlling the surface runoff and protecting the surrounding area with the UTHM campus. So yeah, this is all from me. And thank you so much for listening to us. Have a wonderful day.